Okay, quick chat then about how my nephron works. Now, we've already gone through how the nephron reabsorbs things like glucose and water and gets rid of urea. But what I'm talking about now is the fine control of the nephron and the collecting duct. Because sometimes we've got too much water in our blood and sometimes we've got too little water in our blood. The hypothalamus is a part of your brain that detects whether or not there is too much or too little water in your blood. And it controls the pituitary gland. The pituitary gland releases hormones. One hormone in particular is ADH, antidiuretic hormone. You don't need to know what that means, but you know, there you go, that's it. Now, ADH can either be released or not be released, so that's the two options you've got. If there's a high amount of ADH released, then you're going to make concentrated urine. If there's a small amount of ADH released, you're going to make dilute urine. But what effect does ADH actually have? Well, let's just say I'm walking around in the desert and there's no water around. I need to conserve as much water as possible. I still got to get rid of urea, otherwise I'm going to die. So I have to pee, but I don't want to lose a lot of water. If I release ADH, if the amount of ADH increases, the concentration of ADH increases, that's going to affect the loop of Henle and the collecting duct. And what it's going to do is it's going to make it more permeable to water. So ADH is a hormone that allows water to leave the collecting duct and the loop of Henle. Brilliant, so I've made concentrated urine and I'm able to get rid of the urea and I'm not dying. But then I get into an oasis and I start drinking loads of water from a lake, and now I've got too much water in my blood, and that means I'm going to die. So what I've got to do now is get rid of all that water, and that means the ADH is going to stop. The ADH isn't going to be released, or there's going to be less ADH in my blood. A lower concentration means I'm going to make dilute urine. And if there's not a lot of ADH, then the loop of Henle and the collecting duct stop being permeable. Their permeability decreases. The amount of water that they're going to let through decreases, which means all the water that's been taken out of my blood, taken in by my Bowman's capsule and sent through the nephron, that's going to stay inside my nephron, go into the ureter, and then to the bladder, which can then be expelled through the urethra. So this is an example of negative feedback. So negative feedback is where a change in one factor leads to the opposite change happening to keep conditions constant. So I'm walking through the desert. I've got to try and keep my conditions constant. So I need to make concentrated urine. That means I'm going to release ADH, and that's going to increase the permeability of my loop of Henle and my collecting duct. Brilliant. When I start drinking, then I'm going to have to make dilute urine to get rid of that water, to maintain a constant amount of water in the body, in the blood. If I get dilute amounts of if I get a small amount of ADH, I'll make dilute urine, which is going to decrease the permeability, which means any water that comes into the nephron can leave. So it keeps level constant all the time.